Welcome back to the Calculus Lecture Series. In this video, we're looking at what we call the quotient rule, which states that if we want to find the derivative for a quotient where we have a term over a term, we can simply find the derivative by plugging into this formula, which states if we take v times u prime minus u times v prime, which is important, you can't change, like product rule, you can change which way that you do it. Here it has to be v times u prime first, and that's all over v squared. So without further ado, let's just get into some problems. I don't think there's much explanation other than getting used to this rule here, right? You need to know this. Let's get right into it. For this first problem, I'll use color coding to make things easier when we get to the more rigorous problems. And quotient rule is notorious for rigor, so be prepared for that. So x minus 2, we'll call that u, right? It has to be u, and we'll actually stay with the same color scheme here. We'll call that, this is u, right? Because it's the top. The top is always u. That makes the bottom always v, right? So we say that u is equal to x minus 2, which makes u prime equal to 1, right? Because x, if we use power rule here for each of the terms, x is just 1, 2, negative 2 is 0. So, and then if we take v here, which is x plus 1, we get the same result for u prime, for v prime, which is just 1. Okay, now if we plug it in here to our formula, we're going to say that v x plus 1 times 1 we're going to subtract that by u, which is x minus 2, and then by v prime, which is 1. And then we're going to put this all over. We're going to put this entire thing all over v squared, which is x plus 1 squared. Now, we could simplify this a step further and notice that we have the 1's and just cancel them out. So let's go ahead and do that, shall we? So we'll say that f prime of x, I'm going to get rid of the color coding here, I apologize. X plus 1 minus x minus 2 all over x plus 1 squared. We could simplify this a step further, right? We have similar terms up here. X minus x is 0, so the x's cancel. 1 minus negative 2, we're adding the negative 2, so that's 3 over x plus 1 squared. So that's the derivative for x minus 2 over x plus 1. All right, so let me just make some room here, differentiate the two. So next we have a very similar problem. We have u and v, I'm not going to color code now, so we have u on the top, v on the bottom. All right, so, and then we'll say that u prime is equal to, bring down the exponent, that's negative 2n, the 1 cancels out. V prime, on the other hand, is just 2n. So we have negative n, 2n. Now let's plug everything in here. So v is 2 plus n squared times 2n. That's going to be minus 1 minus n squared. And then v prime, which is also 2n. And yeah, u prime's negative, so we're going to put a negative sign. And then over v squared, 2 plus n squared squared. So that's what we're working with. Let's do a little bit of distribution. Sometimes, and this won't be for all these problems here, for the 3 that we're doing, but you might have a common factor. Like if I have 2 plus n squared here, and I have 2 plus n squared here, I could take out a common factor and cancel out one of the bottom v's, so to speak. But in this case, we don't, so we can just do some simple simplification techniques to get our final answer. So negative 4n plus negative, or sorry, that would be minus then minus 2n to the third quantity subtracted by 2n minus 4n to the third. So we have that term there, all over 2 plus n squared to the second. Alrighty, we do another simplification. 4n minus n is negative 6n. And then we have negative 2n to the third, and we're adding 4n to the third to that, so that is plus 2n to the third. We put that all over 2 plus n squared to the second. I'm thinking, can we take out a common factor? No, we cannot. I don't believe. Or could we? If we bring out a 2 plus n squared. Oh, I think we can actually. Let me think how we could do this. It would be... Nope, we can't. We can't do that. Nope. Okay, so this is our most simplified term here. This is what f prime of x is equal to. We have a final problem here, and this one is going to be quite extensive. Oh God, help me. Save me, Jesus. Okay, so I'm going to push us over here a little bit. These kind of problems can get a little icky, so we'll identify, and over here we'll actually identify u is equal to x squared minus 3, making u prime 2x. We have v, which is equal to this big term, and to keep things simple, we're actually going to go ahead and distribute that, because if you notice here, if I were to take the derivative of this, I would have to do product rule. But I can actually just skip that. Don't make things harder than they have to be in calculus. I forgot where my calculator was. It's in my pocket. Jeez Louise, who doesn't have a pocket calculator? You noobs. Anyways, so I'm actually going to do some distribution here to make this a little easier. So this is x to the third, and then plus 2x squared, and then we're going to take the 5 plus 5x plus 10. So v prime in this case, we're going to just do power rule of everything. Notice how simple that is. Notice how simple that is. We could have done the product rule and we would have been here forever. But we're going to make it a little easier on ourselves and just do it like this. Right? When I teach math, I like to say do things a little easier for yourself. You won't lose your mind in calculus. Okay, so let's now do our quotient rule here, because the terms are divisible now. So we have v, which is x third plus 2x squared plus 5x plus 10. Okay, times u prime, which is 2x, minus u, which is x squared minus 3 times v prime, which is 3x squared plus 4x plus 5. Now this is where it gets a little crazy. And we need to take x third plus 2x squared plus 5x plus 10. Okay. It gets a little crazy because now we have to distribute everything out, and that is a total pain in the ass. So let's go ahead and do that here. I'm trying to think if there's any way we could have a common factor. Nope. Doesn't look like this is factorable. To cancel out the denominator, make it a little more simple. That's the first thing you should look for, actually. See if you have any of that. If you don't, you don't. You know, sometimes it is what it is. Okay, so we're going to say that f prime of x here is equal to, and we're going to have to distribute this, so 2x to the fourth plus 4x to the second plus 10x plus, or 20x squared, should be 4x to the third, plus 20x. Okay. Oh, this is rough. Okay, so, we have to FOIL it, dear God. Okay, 3x to the fourth plus 4x to the third plus 5x second. There's no way you guys are going to be able to see this. I need to move you all the way over here. Jeez Louise. Okay. 3x to the fourth, 4x to the third, 5x squared, minus 9x to the second minus 12x minus 15. Holy crap. Okay, we're going to put this all over. X to the third plus 2x squared plus 5x plus 10. Oh, geez. Okay, so let's do another simplification here. F prime of x, and we're just going to combine any like terms and subtract them over. So we have a x to the fourth here, we have an x to the fourth here. Subtracting by each other, that gives us negative x to the fourth. Our x to the thirds, we have one here and one here. They are just going to cancel, right? Because it's a positive and then we're subtracting it. For our x squareds, on this side we have 10. We have 10. We subtract by 5 here. We add by 9 here. Add by 9 there. We get 14x to the second. Okay, now for our x terms, we have 20x minus 12x, so that's adding 12, so we have plus 32x. We're subtracting by a negative 15, so we're adding 15 in reality. And then this is all over x to the third plus 2x squared plus 5x plus 10 squared. Holy crap. That was a lot. That's the derivative. Thank you guys so much for watching. I am going to go rest my voice because it hurts to make lecture videos about the quotient rule. God bless you guys. Have a wonderful day.